today I have three motors I want to share with you. Starts with a small 120 volt Tecumseh starter motor, quite powerful actually. It's 13 amps. Wanted to show you, this is a the rotor is run with brushes, so you have 4 brushes on this one here. The next one is a temper motor. It's a 3/4 horsepower, which you would typically find in industrial applications, or if you have tools at home, a lathe, grinders, table grinders. Comes with a capacitor, and it's an induction motor. Quite interesting, very efficient. I'm going to open it up, I'll show you the difference. And then the next one would be a Leeson 1 horsepower. This is my favorite. I use it for my lathe. Quite powerful, quite efficient. I had to do some maintenance on these motors, so I took the opportunity to show you how to maintain them, take them apart, break them all down, clean them, inspect them for rotor problems, check the bearings and whatnot, and then you have to lubricate them. So I opened it up, so I wanted to show you the interior. This is the rotor. I'll take it out, I'll slide it out for you, you'll see. This is what gives the torque on the motor, the shaft basically, the wound rotor. Here you have the power coming in, you have the black and you have the white. They send the power to the brushes. You have 4 brushes here, which are basically carbon brushes that rub against to give the electromagnetic field that you to give it to turn the shaft. For maintenance purposes, when you open this up, you have to obviously inspect the brushes, make sure that they're long enough. They come out, you can easily pull them out. I'll just show you how to see. As soon as you move the rotor, the brushes snap, so you get to actually see them. You can pull them out from the back. They're connected with a spring in the back here, so you could pull them all out, but they all look in good shape, the brushes. So we're just going to give it a little bit of a cleaning. So I just wanted to show you, you could pull out the rotor. So here you have the copper all wound on the rotor, and they're all separated with an insulation wire. So this is where the brushes, you see the sealant here, this is where the brushes rub basically to give it the magnetic field so that it spins. So basically what we're going to do to this one is just clean up the bars here, inspect it for uniformity. The number one problem with these type of motors obviously is the brushes. They wear out because as they spin, they basically, you could see they put a groove in the brushes, so they wear out. You may have to change them occasionally. That's about the only thing. Inside you have what they call a stator, which is where it rubs against. So whoop, there's a washer. So if you put this in, there's an equal gap, and it spins. When it does the electromagnetic field, it spins inside there. So basically you would have to clean the inside, all the soot that's there, so that it doesn't rub and doesn't create any problems. And likewise on this one here, you have to inspect that there's no dents or divots, debris. If you see, for example, in this particular case, there's a little pieces of metal that are sort of protruding, that for some reason with the time the debris got in there. Well, I would just clean them with a little file, just to put them leveled, to give it the balance it needs when you put it in. This one here has brush, it's a brass, it has a brass, basically no bearings on this one, just a brass sleeve to hold it in place, so that this is the inside. So you just have to make sure you grease that up so that it gives it, you lubricate it with lubrication oil, which is a petroleum oil. And then the inside, this is very simple, very low maintenance. Just occasionally you have to take care of it and clean it. That's about it. Moving on to the next motor. This is the temper, 3/4 horsepower. I just took the pulley out. There you go. You just see it right off the bat from the interior. This is what you see. Look at all the dust that's in here. This is typical maintenance that you would have to do. I'll just turn this around so you get to see a little bit on the inside. So this is what I clean. This is all the debris that gets. This one here is also an induction motor, but it somehow doesn't have a little fence. Usually they put a little fence. I believe that one there I can see through the little grill that they do. This one has no protector, so look at all the sawdust, whatever it is that you're using, which could contaminate the interior of the motor. This has to be cleaned on a regular basis. So here's the rotor. I'm going to pull this one out. Well, I have to turn it around, I guess. Let me pull out the other side first. Just take out the holding pins. And here's the just wanted to show you here, this is the reset button. So if it overheats, this is the capacitor here that goes on top. I will open up to show you the interior. There we go. So this is the interior. Hope you get a good view. This is all the coils of the starter, what they call the stator inside. This is the rotor on this one here that you get to see. Let me just turn this around here so you get to see. So this is the way it goes in. I'm not sure if you get to see all the dirt in there, but there's all these coils that are wound up here. So if you have a single phase, like this is a single phase basically, you have one, the continuous wire that goes in, comes out the other end, and it's all connected to all these electromagnetic field, the stator, what they call the stator, and it's separated with insulating paper in there. So basically you inspect all of this to make sure that there's no burnt wires. Obviously if there would be a burnt wire here, something burnt, the motor wouldn't work. I notice here there's just some protruding piece of metal, again like similar to the other one, the other motor. This is debris that gets in here, and then with the heat, you get to, a little hard to see the inside. Should have had a flashlight in here. Let me get a flashlight. So here we go. I got my little flashlight here. So you get to see the interior. You got to really inspect it closely, but as you could see, it's really filled with debris in here. This would require a nice, cleaning. So I'll bring it up in the garage and use a compressor, the air hose, and clean the inside properly. And at the same time, I'll inspect it and maybe use my little brush, my little compressor brush, to just clean the inside without damaging the interior. So these bearings look really good. I just have to clean them and re-grease them up. This is the switch plate. So if you push here, I'll show you on the other side which there's a stationary and there's a moving switch that goes down. So that's how it makes contact with the brushes. But the rotor here, it looks really good as well. There's aluminum with the fins, which cool it down when it's turning. So again, you need like a really good clean. Look at all the sawdust that's in there. So quite a bit. That could damage it, because as it gets warm, the hotter it gets, the more the temperature rises, the more that the metal, that's the coil here, the rotor, will expand. If it expands and rubs on the inside of the rotor, because this is the front part, see, it's got to be, look at this, I'm lifting both sides just to relieve the pressure, and it smooths, it rolls pretty smoothly without rubbing. But as soon as you bend it a little bit, it jams in place because it's too dirty. It has to be in there perfectly, equilibrium between the weight. So both both bearings look okay. Just have to clean a little bit. So here's the back side. Let me put this back in so you get to see. This is the back side that goes in here. So this is the reset button, like I showed you here. Overload, thermal overload button. If it's automatic, if it overheats for whatever reason, as I said, if you're overusing it, whatnot, it'll overheat. It'll trip the reset button, and it'll shut down the motor, so you protect the motor. Here's the switch where the power comes in. So the two sides, same thing like the other side. Basically, it's like these are stationary brushes that move here, that you can see, stationary. So they rub and they make contact here with the other switch on the inside, which then lets the electromagnetic field take effect through the shaft here, and then it starts turning. So this is the temper, and so this is the Leeson 1 horsepower induction motor. So I'm going to just take the flywheel off, loosened everything. There's the flywheel. Comes with the little key. Don't lose the key. Go in there. Here we go. So here's all that. Connecting rods. Here's the end sleeve. Pretty damaged with time. Looks fairly clean on the inside. Let's take the back off first. This is pressure fitted. It's the washer, the ball bearing bearing washer. It's pressure fitted in there, so you gotta be gentle so you don't bend anything. There you go. See, this is the bearing in here. There you go. So you see the little bearing. Well, actually it's a pretty big bearing here, really big. Here the switch is in the back. Here, I don't know if you can see it. Here's the switch in the back. These two little copper plates here, they make contact, and that's what gives it activates the other switch with the brushes here. This one's much larger, pretty rusted, as you can see. So this needs to be polished. You inspect the bearing here. Bearing looks okay, just really filthy and dirty. I guess there's a lot of debris in here. Also rusted, needs to be sanded. And I'm probably going to use a little bit of sandpaper to clean the inside. I'll have to take this all apart. This is a regulator here, but it doesn't have an automatic. You can't reset it yourself. So it's automatic. It sets by itself. As you can see, there's nothing on the outside. These motors are really old. I mean, this is 89 years old here. One of the main faults that they were saying that happens with these is the 42% of the time it's the bearings that give out, because this is basically the weakest point. It's the weakest component, because there's two bearings, one in the front and one in the back here. And basically this whole, I can't describe it to you, but this here must weigh about 15 pounds, 20 pounds. And if you think about it, it doesn't sit on anything. There's an equal, basically an air, a magnetic field between, oh look at this, it even has a plate to protect it from debris. That didn't work out. So as you see, when you put it in, it slides in. It's really not touching. It's touching now because it's sitting, but if I lift the back, the bearing, it has to have an equal space. So it's just the electromagnetic field that keeps it from turning. So you get power going in goes to the stator over here, then creates the magnetic field, sort of like lifts this, and then starts spinning it on its axis. So it's pretty heavy. So the number one problem, as they say, fault problems, are these bearings over here. I mean, you gotta inspect it. And one way of knowing if the bearings are okay is that it doesn't have any discoloration. Here you still see it has a little bit of grease, not much bearing grease, needs to be cleaned with a nice wire brush, but it doesn't have any discoloration. As long as it doesn't have dark blue discoloration, then it means that the bearings are still okay. I wanted to also show you that it has, I don't know if you could see it, but it has wiring for the different types of rotation. So if you want a clockwise rotation, you use one form of wiring. Here, this was the plate that was behind it. Here you go, so you can see it better like this. So I'm not sure if you could see it, but counterclockwise rotation, CCW, counterclockwise rotation, and clockwise rotation. So you could basically let this shaft turn in any which way you need for your lathe. That's why I like it. I can change depending on how I install it. If I install it underneath the table, then it needs to turn one way. If you install it on top of the table, it's a different rotation. I installed the rotor on my lathe, and I devised this little jig here just to see if it's balanced, and it's got a point on it. So just to give you an idea, this is a piece of sandpaper. I put it so close that not even a piece of paper fits through, like 1 micron I would assume. It's just to see if it touches anywhere. So if the rotor expands due to overheating or contamination of debris or liquids that get in here, it could have adverse effects on the motor. Obviously, it shortens the lifespan of the motor. So just to give you an idea, I put it on the lathe, I balanced it out, it's all leveled, and I put my little point on, and there's no deflection, no. So I'll put some sandpaper on my little disc sander here, so that I could just polish up the rotor. Do a nice little job there. So here's the finished version. Did a nice job sanding it. Looks all smooth. Inspected all the little bars, no cracking, just divots from usage, normal usage, but it's fine. Motor's all acid washed, cleaned, and ready to be painted. So stay tuned, I'll show you a little bit, but I gotta shut the camera so that the paint doesn't go all over the camera. So I'll just give you a little bit of an idea of what it looks like with the vintage green. You gotta put very light coats. I'm gonna put about 2 coats all over gently. It's a very nice paint. There we go, we're all done. 2 coats, beautiful job. Look at this, I can't believe it myself. Well, right now we're at the final stage of the assembly of the Leeson motor. I even re-put back the label with some contact cement so that you get all the specs on the motor. This is the rotor, so I have to put the rotor back in with some grease. These are the bearings, as I mentioned, so the rotor's all cleaned, as I showed you. The fins are painted so that no debris will stick to it in the operation. The end, I put the baffle in also so that the dust doesn't go back in, so it's all nicely cleaned and put back in. So here we go, we're going to start putting some grease around the bearing, as I said, the most important part. But make sure you get the good bearing grease, which can withstand temperatures of 540 degrees Fahrenheit. It's specially formulated for wheel bearings, and it's resistant to acid and water, of course, because of the oil. So I like this when I use it on a lot of the projects. The make doesn't matter, it's more of the quality. So just you liberally put it on the grease, on the bearing. Should be done regularly. This is the bearing that's going to go in the housing. So basically all of the weight is basically suspended with these two bearings. So I do the inside of the housing as well, because it's a little bit of a pressure fit. And now we pressure fit this in. The way I do it, not to damage the paint, is I have my little pieces of wood with a little bit of silicone grip on it. So I basically put it on top so I don't damage the paint, and I tap it. Has to sit even. See, and you feel it. There you go. And so this is it. You inspect it, so it works fine. So now you just have to, this is the front end, put it into the, as we mentioned, into the baffle there. Remember, this is the capacitor that's going with the lines, so I followed the clockwise rotation schematic supplied here. You'll have either, you could do it counterclockwise or clockwise. Again, grease the other end generously, nice amount. Do the bearing here as well. So when we pressure fit it, it sits on the other end here. There we go. So now we put it back in gently and give it a try. The moment of truth. Very good. Last step, just putting in the pulley. I put some grease in, putting the wedge. Oh, all done. Let's see if it's balanced with the pulley. Beautiful, look at this. It's quiet. So here are the three induction motors that I undertook to clean, restore, paint, polish, and you know, put back together. So here they are, finished. Just going to show you this one I have to lift. It's a very powerful starter motor. Just show you how. So it's a fairly rough motor, good condition. I'm going to use it for, I was asked to do an edger, a leather edger, so I'll be using it shortly. I'll be showing you how I'm doing that. Second one is the temper motor, double shaft here. It's a double shaft, so you have double pulleys, useful for many activities. So here it goes. So very, takes a little time to start, very quiet, very handy, very practical. And last but not least, my favorite, the 1 horsepower Leeson. Here you go. Works great, it's balanced, fantastic. I hope you had fun watching this video. I had a blast. It was exciting. I like doing these little hobbies, so thank you very much for watching, and stay tuned for others.